My topic for this semester is the coevolutionary arms race between rough-skinned newts and gardener snakes. The thesis statement of my paper is as follows. A coevolutionary arms race between rough-skinned newts and gardener snakes is displayed by TTX concentrations that offer rough-skinned newts resistance to toxin of gardener snakes, which then develop resistance to the TTX. Interactions between predators and prey are very significant in the understanding of evolution. This relationship between rough-skinned newts and gardener snakes can be helpful in the understanding of coevolution, which is very important. Coevolution is one of the many things that is important for shaping the biodiversity of species. The interaction between these two organisms is a great example of that, and this topic will allow me to address how coevolution occurs and what leads to an arms race between two different organisms, including the interactions amongst toxic prey and their predators. Lastly, this is significant because it will allow me to explain how mutations can be used in evolution. The figure on this slide will be important when I am trying to explain how mutations have influenced the coevolution between rough-skinned newts and gardener snakes. This figure specifically improves your understanding of the mutations in gardener snakes. Since the TTX of rough-skinned newts obstructs the sodium channel of skeletal muscle, gardener snakes have to evolve resistance to TTX by the development of alterations in the amino acids of the sodium channels in their peripheral nervous system. The top portion of this figure, labeled A, illustrates the substitutions of amino acids in 6 sodium channels of a species of gardener snake. The amino acids that are underlined represent those that influence the binding of TTX. And the amino acids seen in red represent the substituted amino acids that favor resistance of TTX. The second portion of this figure, labeled B, displays the amino acids that are substituted in the sodium channel. In the end, these mutations can cause changes to the shape of the receptor that the TTX typically binds to. In conclusion, this figure shows that the resistance seen in gardener snakes evolves exclusively in the sodium channels that come in contact with consumed TTX, which will allow me to explain this interaction and will help my audience better understand the mutations that influence the coevolutionary arms race between rough-skinned newts and gardener snakes.